Today, let's talk about something that's always on the top of everyone's mind, which is about controlling costs and saving money. What we've seen in the past year or so is a lot of people are moving workloads as appropriate up into the cloud. Obviously, the public cloud gives you anywhere access, it gives you ways to expand and contract your capacity. But the key is that if you're not careful, that can, as you've seen probably, spiral out of control, and you end up with storage costs and egress fees and compute costs that you just hadn't anticipated. So let's talk about how Leostream can actually help you control that in a VDI deployment. So to do that, let me share my screen and show you some of the functionality that's in Leostream that helps you control cloud costs. So I'm going to sign in here as the main Leostream administrator. And when I do that, you're going to see the admin portal open up. Now, I'm not going to go through an entire demo here. I just want to, as I mentioned, highlight the pieces that are important for saving cloud costs. So to do that, let's look at pools and plans and then see some end user experiences. So first, pools in Leostream are essentially groups of desktops, and ultimately you're going to offer users machines out of these pools. Now, the key about pools when you're working in public clouds, and that can be AWS, that can be Azure or Google Cloud Platform, the key here in Leostream is that it automates expanding the cloud footprint and contracting it based on the user demand that you have at the time. So as an example, here I have a pool of machines that I've called my non-persistent machines. The idea here is I'm going to create some machines that are kind of standbys, and you see right now I have one. So that machine is ready for someone to grab. And now when a user grabs that machine, I want to spin up another one so that there's a machine waiting for the next user. So how is that done here in Leostream? Well, here in the pool definition, I've defined what are the machines that are in this pool. And I usually do it very simply based on the desktop name when I'm provisioning, because I have control over the name when I'm provisioning. So those are my initials. Anything that starts with my initials is going to end up in this pool. And I should say I'm provisioning to AWS East here. So first it has to be in AWS, and then it has to have my name. If I come down here, then here's where you control when does the broker do the provisioning and how is the provisioning done. The provisioning limits here, this tells us when do we provision. As I mentioned, I have one kind of hot standby waiting, but obviously I want to make sure I don't keep provisioning in the cloud so I don't have unexpected cloud costs, so I can put a cap on the sides. That's also great in the cloud because some clouds also impose quotas on the number of types of instances that you're allowed to launch or the amount of money you're on to spend. So you always want to have some sort of threshold at which you stop the provisioning automatically too. Now, static limits are great in certain situations, but in other situations, it's better to be able to schedule this provisioning. For example, if you are actually hosting a classroom application up in the cloud, you want the application available during the class. So in that case, there are options for scheduling the time of day. So I could set my static limits to 0 so that the pool is empty, and then set a days and times during which I actually want to automatically spin up a suite of machines that are ready for whoever happens to need them. So provisioning limits here help us determine when do we provision a machine. The provisioning parameters then tell the broker how. So the first thing to do is to say, where are you provisioning? In this case, AWS East. There's this name that I mentioned I have control over when I'm provisioning. And then a lot of these other options are what you would select and set as you step through the launch wizard in AWS. So the options you'll see there will vary based on the cloud you're provisioning in. Azure and Google Cloud Platform both need different information. But here I'm selecting my base image. Now this is a key when provisioning in Leostream. You're going to first, in whatever cloud you're working on, build your base. And that can be Windows or Linux. It can have whatever applications you want on it. And it should be running our Leostream agent, because that's the key piece that's going to give you real good control over your environment in the cloud. The agent's going to let the broker know, when did the user disconnect? Have they gone idle? Did they log out? And then the broker allows you to automate power down or even termination for those instances based on those agent events. So always make sure the agent's on your master image and talking properly with your connection broker. And then here, obviously, I sent an instance size. We support a wide number of sizes, obviously in the cloud. The key is to always pick the smallest size that you can use and still satisfies your end user's needs and performance requirements. Again, smaller the size, less you're going to pay for it. And then I just set my network and my security group. And now here, I'm marking this machine as deletable. What this pool is modeling, as the name implies, is a non-persistent workflow. A user is going to log in, they're going to do their work on that machine, they're going to log out, and the broker is going to terminate that machine, completely delete it, delete its volume so you don't have any accidental storage costs kind of building up in the background as well. So pools, it's the start of how you control costs. Create a pool, make sure you don't provision too often and too many. And then what you need to do is say, okay, well, how am I, once the machine's provisioning, how am I controlling the backside? When is it powering down? When is it getting terminated? That's done through plans. I'm going to skip right over to power control plans. Power control plans automate power state. So when we provision a machine, it's provisioned running so that the user can connect. And then you want to say, well, when do I shut it down? If it is a persistent machine, it's a machine a user always owns, or maybe it's a shared machine with an application, you just never want to terminate it. You still want to shut it down when it's not in use. And so here I've created a power control plan, and it, as the name suggests again, shut down on logout. So here, the way this form reads, it has these headers. Did the user disconnect? Have they logged out? Did they go idle? As I mentioned, these are the events coming from the Leostream agent. And so now I can perform actions based on those events. Here, what I'm saying, if the user disconnects, now, if you think in terms of RDP, I launch my RDP session and I can click the little X at the top right, that disconnects from the remote machine, but I'm still logged into it. The agent recognizes that as a disconnect event. Perhaps if it's a disconnect, well, you're assuming the user is coming back, so I'm not going to change the power state. But once they fully log out, well, here I'm going to in my case, I'm waiting a minute and I'm going to shut down. I choose a minute for demo purposes, but you can set this to whatever time frame that you need. Well, that's great. So if the logout happens, I get a shutdown in a minute, but the disconnect's not triggering anything. So how do I protect against users who don't realize that they disconnected instead of logged out? This can be handled through release plans. So here I have a couple of release plans to show you as an examples. The first is to model that non-persistent workflow I talked about, delete on release. Again, you see this form is based on the different user events. Did the user disconnect, log out, etc. So if I read through this, the way it goes is the user disconnects this time. They click that little RDP X. Well, I'm going to wait an hour. This gives them time. Maybe they did disconnect because they just went to lunch. They are, in fact, coming back. If they come back in an hour, we get a reconnect event from the Leostream agent, and we'll cancel the logout jobs. If they don't connect, it was the end of the day and they meant to log out, but they hit the button. Now, after an hour, the broker is going to tell the agent, forcefully log that user out. When the user gets logged out, the agent sends a logout event, which then triggers this section of the plan. So there's some of the real power of the release plans, is that the events trigger one another. And so you can model a lot of different types of workflows. So disconnect after an hour forces the logout. The logout says release the machine to the pool immediately. So when the user connected, they got assigned to that machine. When this release to pool action occurs, the user that assignment gets released. That then triggers this section of the plan down here, which says go ahead and delete the machine from disk immediately. Now, I will mention that when you're talking in Azure, when we delete a machine that we've provisioned, we delete all the pieces. So you won't have extra NICs hanging out in Azure or other different components that are associated with that machine that you might not realize have gotten created when we spun the machine up. Just to kind of follow through the final piece of this particularly release plan, it also is checking for idle time. So if the user disconnects after an hour, or if the user is idle for an hour, I should say, they went to lunch and forgot to hit the X button. After an hour, it will perform the disconnect. So this not only helps trigger the rest of the events in the release plan for cost saving purposes, but it's a nice security feature. You can track if someone's not working, and that way you can close their session so it's not just open for other people to wander past and look at. Again, that disconnect triggers this section of the plan and follows through the rest. So that's a great way to model that non-persistent workflow. Now, what about a more persistent, a shared machine or something? Here I have another option, which is log out on idle. In this case, I'm still checking the disconnect. If they disconnect after an hour, log them out. But now this one, because I want to show you how this one actually works, I've set my log out after idle to 1 minute. So if we launch the connection and we don't touch the keyboard or mouse for a minute, after that, the agent's going to log the user out. That's going to trigger the when user logs out section of the plan, which this time immediately releases the machine to the pool, which then triggers this section, which isn't going to terminate the machine. We're going to leave it there, but it's going to log the user out. Now, if you follow through that logout event, it's not just executing the logout sections and release plans, it's executing the logout sessions in the power control plans as well. So if I have a release plan that logs the user out and the power control plan is set to shut down on logout, now the machine gets powered down. So I just see there's a lot of logic that's going on in the background here. But again, the idea is you set this up once and then everything is automated for you, with the goal being minimize the cloud costs. Just to show you how this all comes together, here I have a policy, and the one I'm going to show is this one, HTML5 RDP desktop. This is going to do a connection via our Leostream gateway using HTML5. So this one is the non-persistent machine. So I've said go ahead and offer a machine. In that case, I've offered 2 machines from the non-persistent machine pool. And I've set the protocol plan and my release plan to delete on release. The other policy I'm going to highlight is our DCV plan. We do support nice DCV, which is a protocol that's built into your AWS costs. So it's a good way to get a really high performant protocol with, again, not having to license additional display protocols, with the goal being minimize your costs. So here I'm offering 1 machine from my DCV pool. Obviously now I'm going to connect using DCV, still via our Leostream gateway. And this one is set just to shut down on logout and also monitor for that idle time. The way these policies are assigned, just so you can see, this is my demo authentication server up in AWS as well. And here I'm going to have 1 user log in from a web browser. That's going to give them the HTML5 RDP desktop. And I'm going to show you our Leostream Connect client, which will launch the DCV connection and monitor for idle time. So since we're going to need to wait a minute for our DCV connection to close, let's go ahead and do that connection first. So here I'm going to log in. Now the user is being offered their machine. Our Leostream agent is starting the DCV session on the back end for the user, and then the connection will be launched here. So there's Milo getting logged in. I can see that all happening here on the log page. So the log page is a great way for keeping track of what's going on in your system. So I see Milo logging in, requesting the connection, the forwarding rule being added to our Leostream gateway, and the agent sending the notice that the user has logged in. So while that's sitting in the background, so it won't notice keyboard or mouse strokes, let's go ahead and show you Mabel's login here. So she's going to log in. She gets a non-persistent machine. This is going to connect inside of the browser. This is going through our HTML5 client. And then what I'm going to do with Mabel here is just immediately log out so you can see the machine get terminated. Log out, not power down. So going back to our log page here, you can see that Mabel logged in and the connection was launched. That pool was set to always have 1 running spare in it. So as soon as she connected, that triggered the provisioning. So the next machine is being spun up. And as she gets unassigned, it will schedule the deletion of the machine. You can see it being deleted right there. While all that's happened in the background here, you notice my DCV client is now back at the client. I'm no longer logged into the machine. That happened because a minute went by of idle time. So you can see the forced out log out here. And then what we'll see here in the job queue is that shutdown after logout job that we scheduled for a minute later. So after a minute of idle, I got logged out. This job got set. If no one logs back in or touches that machine in that next minute, it's going to get shut down. And I could see all of this happening here inside of AWS. So this is the new machine that was created when Mabel logged in and grabbed the first one. Somewhere down here, I should have it terminated, the first machine. And if our minute has gone by, I should see the Windows machine start to power down as soon as that minute goes by and that job executes. See, it's still pending, still got a few seconds to go. So that is the key between the power control plans and your release plans and the ability to expand and contract the cloud using pools. You really have a way to help you lower your cloud compute costs. And beyond that, the other things that you can do, I mentioned using DCV so you can avoid licensing fees there. Leostream does support a wide range of display protocols. So use the, kind of like I said, use the instance size, that's the smallest for the user's performance. Use the display protocol that gives them the performance they need without paying for extra. So RDP where it's appropriate, VNC, or nice DCV with a nice GPU enabled instance if you need that performance in the cloud. A lot of flexibility and ways for you to design the system to suit your users' needs while also not overpaying when you don't. As you saw, there is a lot of logic. There are a lot of options. So if you need help or setting it up, getting it configured appropriately for your environment, we're always there to help. If you want to try it yourself, just drop us a line at sales@leostream.com. Thanks.